Question 19 pertains to taking a polar equation, which is the r equals equation, and converting it to a conic equation or rectangular. This question, I'm not going to lie, isn't the prettiest question. The best way to solve this one would not be algebraically, but rather entering this into the calculator. If we go to our mode and we change our mode to polar, that's what r equals equations are, we also have to change our mode to radians since we're entering in theta next to that trig function. I'll go to y equals, create a fraction, and enter in this equation. 8 over 16 plus 125 sine theta. For theta, I just hit x and it gave me that equation. This equation traces out kind of slowly, but it looks kind of like a really flat parabola. But before you get too excited, I'm going to zoom in right around where it kind of was taking its time to trace a little bit towards the origin. I'm going to continue to zoom in. And as I continue to zoom in, it's starting to kind of break up and look like something that's not a parabola. This actually is going to trace to be more of a hyperbola. Like I said, not the best question, but you can graph polar equations in order to see what their rectangular behavior looks like. You could see a circle, an ellipse, a hyperbola, a parabola, many things. Number 20 deals with a cardboard box, and we cut the cardboard box at the corners. The dimensions of this cardboard box, it says that the length is 4 times the width, but we don't know what the width of this cardboard box is. So we'll just call that x. The length we know is 4 times the width, or 4 times x. Then we cut the box 3 by 3 all the way around those little squares. So now the width is x minus that 3 and the other 3. So the width is going to be equal to x minus 6. The length similarly is 4x, but then we trimmed off 3 inches on either side. So it's 4x minus 6. So there's the width and the length. But this question's asking us about volume, and volume is length times width times height. And the height of this box would be 3 inches if we fold up those 3-inch squares that we cut out. So now what we're being asked to do is calculate the width of the cardboard that he started with if the volume is going to be 336 cubic inches. We can jump straight to our calculator now that we have this set up. We go back to our function mode. Degrees, radians, it doesn't really matter, but we can enter this in as 3 multiplied by x minus 6 multiplied by 4x minus 6. Our y2 we can have as 336, and before I graph that, I know I'm going to have to change the window. The window, the y max, mine's a little funky right now, but the y max should probably be 400. So let me maybe adjust this. Go back and just have it be the standard 10 by 10 window. I'm not going to see a whole lot going on though. So let's go ahead and change my y max to be 400. I just chose a value that was larger than the volume, 336, so then I could see where this function intersects the volume. We see 2 points of intersection. The one over on the left doesn't mean anything to us, however, because you can't have negative length or negative dimensions. So we're going to second trace intersect over in quadrant 1. Moving over. And we'll intersect right around there. And the x value is 9.5. Once again, this question was asking us what is the width of this cardboard box, and the width is equal to x. So 9.5 inches is our answer. Number 21 goes back to Unit 4 where we were doing trig identities. We can rewrite secant as 1 over cosine theta multiplied by sine theta. And we can also rewrite tangent as sine over cosine. Now we need to kind of clean up that fraction within the fraction. So if I multiply by the reciprocal, I get 1 over cosine theta multiplied by sine times cosine over sine, which simplifies to just cosine. 1 over cosine multiplied by cosine just becomes 1. That doesn't match any of our answer choices, but these are all squared, and that reminds me of my Pythag identities. Sine squared theta plus cosine squared theta equals 1. Well, that doesn't work for choice A or B. The other trig identities that we have, me plus my tan, is sexy, but we're not dealing with any of those trig functions, so it must be the third one. Me plus my coat is cozy. If I rearrange this, cosecant squared minus cotangent squared gives me 1.